Mommy's gonna do some train problems. Pay attention.
Okay guys, so this is going to be some difficult problems. It's called uniform motion problems. You're probably going to have to watch this video a couple of times. I do want you to pause me throughout and make sure you write everything down. But once you get it, it'll be fine. It's just going to take a little bit to understand these. We're going to go through 3 basic types. The ones that you see where objects are moving in the same direction, objects are moving in opposite directions, and then we're going to learn how to calculate average speed. Okay. Before I talk to you about those 3 types of problems, we have to remember the distance formula. So here, I know my recording is in the way. There we go. So the distance formula, or distance covered, equals rate times time. D equals RT. What did I just get rid of? There we go. Sorry, my picture. Okay, so for example, if a car is going at the rate of 40 miles per hour, then in 2 hours, and we wanted to figure out how many miles it was going, the distance covered would be 40 times 2, which is 80 miles. So just to kind of refresh, well, we had miles per hour, and then we gave 2 hours. Why does our answer change into miles? Well, with our conversions, we know that 40 miles per hour times 2 hours, we did this in dimensional analysis, the 2 hours end up canceling each other out, so you end up just getting an answer of miles. So 40 times 2 is 80 miles. Okay, so remembering this stuff, let's look at our first type. Okay, pause, write all this down, and then follow along as I do it, because it's a difficult problem. Okay, a train leaves the station at 1 p.m. It travels at an average rate of 60 miles per hour. Oh, let me get that back here. Okay, so, and a high-speed train leaves the same station an hour later. So we have one train is going at 60 miles per hour. We have a second train that's going an hour later. It travels 96 miles per hour, so it's traveling faster. The second train follows the same, and let me pull this down so you can see that. The same, that part is very important. Right here, the same route as the first train on a track parallel to the first. In how many hours will the second train catch up with the first train? So it's important to, when you're thinking about this problem, we have 2 trains and they're going in the same direction. Okay. So we're going to let T be the hours traveled by the first train. All right, so if the first train is going at T, the second train, if you think about it, it left an hour later. But we want that to know when they have the same distance covered. So if it left an hour later, its time is T minus 1. It left an hour later. That's traveled by the second train. Okay. Sorry, my recording is getting in the way there. Okay. So, since the distance covered by both trains is the same when they meet, train A covers 60 miles in 60 times T. It covers 60 times T miles because we don't know how many hours we're spending until it gets to the same spot. Train B covers, it goes at 96 miles per hour, so 96 times T minus 1 miles. Okay, so this should kind of relate to what we were just talking about. Now, we know that they are going to travel the same distance. That's what we're asking. When will they catch up with each other? So we have that. Just want to, and all we have to do is solve. Now, there's a little table here set up for you. This might help you as well to list the 2 trains, list their 2 rates. That's what I have over here. There are 2 rates, 60 and 96. The time for the first train is T, so the other train has to be T minus 1 because it left an hour later, and we get this. So if you like to set up the table, you can do that. That helps you. Then we write our equations set equal to each other because they're going the same. We want to know when they are the same distance. All you then have to do is solve. You distribute, and we get that. We combine like terms. We bring the 96t over to the left. You get negative 36t there. Divide both sides by negative 36. Okay, so our time is 2 2/3 hours. Now that t, remember, that's the time traveled by the first train. We wrote that right here. Now let's go back and look at our question. It said, in how many hours will the second train catch up with the first train? So it wants to know the second train's hours. So we have to remember, we're going to substitute that in, t minus 1. We'll get, since train B takes an hour less, it will take train B 1 2/3 hours to catch up. So that should be your sentence that you should have written at the end. I don't know why I won't switch over to that. There we go. It will take train B 1 2/3 hours to catch up. That would be your sentence at the end of the word problem. Okay, so that was our first type. Our second type are objects that move in opposite directions. Okay, so pause, write all this down, and then follow along as I do it. Jane and Peter leave their home traveling in opposite directions on a straight road. So one's going one way, one's going the other way. Okay, Peter drives 15 miles per hour faster than Jane. After 3 hours, they are 225 miles apart. Find Peter's rate and Jane's rate. Okay, so I'm going to move this. Important thing to note, you might want to put this in highlighted box on your notes, is you should let the smaller rate to be R. So since we know if Peter's driving 15 miles per hour faster than Jane, Jane is not traveling as fast. So we're going to let R be Jane's rate. All right, we're going to set up our table. Going down the sides, we have Jane and Peter. Going across the top, we're going to have our rate, we're going to have our time, and we're going to have our distance traveled. So those are the important things we need to find. Okay, the rate for Jane, well, we just said R is going to be the rate for Jane because she's traveling slower. So Peter's rate is going to be 15 miles per hour faster, so rate plus 15. Jane's time, well, it says after 3 hours, and we're talking about both of them. They're both 3 hours. Distance travel, well, distance equals rate times time. D equals R times T. So 3 times R and 3 times R plus 15. Okay, so now we're going to put all this together. If they're traveling in opposite directions, we have this one going to the left, that will be Jane. And to the right, we have Peter. Together, they are traveling the same they're traveling a distance of 225. So we need to figure out what together means, what operation we're going to be talking about plus. So these two being added together is going to equal 225. And that's where our equation comes from. 3R plus 3R plus 15, the quantity R plus 15, equals 225. Okay, so we distribute. When we get that, we combine like terms. 3R plus 3R is 6R plus 45. Subtract 45 to both sides. Divide both sides by 6. We get that our rate is 30. So now let's go back what the question said. Find Peter's rate and Jane's rate. So they want both. So if Jane is R, which is 30 miles per hour. Peter, we do 30 plus 15. And we get 45 miles per hour. Those are our two sentences for our word problem. Okay, the third type is calculating the average speed. So what's important here is that you're not going to just take the two speeds and average them together. You have to find the average speed by doing the total distance over the total time. I would put this inside of a box. I would highlight this on my notebook. Make sure you know that that's how to find the average speed. Okay, so let's look at this. Joe drives 120 miles at 60 miles per hour. Then he drives the next 120 miles at 40 miles per hour. What is his average speed for the entire trip in miles per hour? Okay, so using our formula, the average speed is the total distance. Well, he drives 120 miles and he drives 120 miles. 120 plus 120. Time. These were our speeds, so you're not going to put 60 and 40 on the bottom. We have to figure out our time. Well, if he was going at 60 miles per hour, that would take him 2 hours to go 120 miles. 120 divided by 60 is 2. 120 divided by 40 gives me 3 hours. So we have 2 hours and 3 hours are our time. Okay, we're just going to do our calculation here. You get 240 over 5. You divide. You get that their average speed is 48 miles per hour. Okay, so we're going to do a bunch more of these in class and practice. That's it. Have a good night.